Section 8.3, Polar Coordinates. In this section, we are going to learn how to plot points using polar coordinates, convert from polar coordinates to rectangular coordinates, convert from rectangular coordinates to polar coordinates, transform equation between polar and rectangular forms, identify and graph polar equations by converting to rectangular equations. In the past, we have learned how to plot the rectangular coordinates. In the rectangular coordinates, we have an order pair x, y. While in the polar coordinates, we have the pair r, theta. The first coordinate r is the radius or the length of the line segment from the pole. The angle theta measured in radians indicates the direction of r. This is the polar grid. If you want to plot the polar coordinates or to graph the polar equation, you have to use this grid right here. In this grid, we do have the vertical axis and the horizontal axis. The intersection of the two axes called the pole. And this is also called the origin, where your r is 0 and your theta is also 0. Let's go ahead and scale the polar axis. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the left side, I have -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Similar to the vertical axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Okay, so let's try an example. Let's try to plot the point 6, pi over 3. This is the polar coordinates. The first coordinate is r, represents the length of the line segment start from the pole. The pole is right here. If my r is positive, I go to the right. If my r is negative, I go to the left. In this particular case, my r is positive 6. So I go 1, 2, 3, 4, 5, 6 units to the right. So this is representing r equals 6. But this is not my point yet. If I plot the point right here, this is the point 6, 0, because the angle equals to 0 here. Now my angle is pi over 3. That means I need to rotate pi over 3. So from here, angle is 0 here. Angle is pi over 2 here. And then the angle is pi here. So if you rotate half circle, the angle is pi. Now you want to rotate pi over 3. That means you are going to divide your pi into 3 equal parts. So if I divide it into 3 equal parts, this is 1 pi over 3, this is another pi over 3, and this is another pi over 3. My point is 6, pi over 3, so I will have the length of 6, and I rotate pi over 3. My point is right here. Let's try another example. Let's plot the point -4, 5 pi over 6. My r is -4. That means from the pole, I move to the left 4 units. From here, I move 1, 2, 3, 4 to the left. This is -4. and I will rotate it 5 pi over 6. Remember, when your angle is positive, you are rotating in counterclockwise position. So from here, I will rotate 5 pi over 6 in this direction. So from here, if I rotate 1 pi, I will end up at this point. Because 1 pi is half of the circle. In order to rotate 5 pi over 6, I need to divide this half circle into 6 equal parts. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. So I start at my -4 here, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So this is the point -4, 5 pi over 6. Let's try another one, 3. Let's plot the point 8, comma, -pi over 2. In this polar coordinates, my r is 8 and my angle theta is -pi². So r is 8 means I will have 8 units to the right of the pole. So the pole is right here, 1, 2, 3, 4, 5, 6, 7, 8. Now, if the angle is positive, I will rotate it in the counterclockwise direction. And if the angle is negative, we'll rotate that in the clockwise direction. So from here, the angle is -pi². I will rotate that in the clockwise direction for pi over 2. So this point is the point 8, -pi over 2. Example 1. Plot the point 3 pi² on the polar grid. They also gave me the polar grid right here. What I'm going to do first is go ahead and draw my polar axis and label them. I have the vertical axis and the horizontal axis. The pole is the intersection of the two axes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5 is -5 here. 6, 7, 8, 9, 10, -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, -5. 6, 7, 8, 9, 10, -10. In this polar coordinates, r is 3 and theta is pi². So I start at the pole, r is 3, and move to the right 3 units, 1, 2, 3. Theta is pi², that means I will rotate in the counterclockwise direction, pi over 2. This is the point 3 pi over 2. Example 2. Plot the point -2 pi over 6 on the polar grid. Again, the first thing I'm going to do is draw the vertical axis and horizontal axis and label them. In this polar coordinates, my r is -2. So from the pole, I go to the left 2 units right here. And then I will rotate in the counterclockwise direction, pi over 6. This point right here. Next, we are going to learn how to convert from the polar coordinates to the rectangular coordinates. For polar coordinates, we have r and theta. For the rectangular coordinates, we have x and y. So imagine if they've given you r comma theta, can you convert that into x and y? Now, imagine if I plot this point on here. I have the point r theta. Say this point. I'm just making this up. So this point is the point r comma theta. What does that mean? It means that the length from the origin to that point is r. And the angle from the x-axis to that ray is theta. Now, it doesn't matter if the point is in polar coordinates or rectangular coordinates, the position of the point is going to be the same. So now, if I convert that into x and y, I would have exactly the same location for that point. So this point in the rectangular coordinate, we call it x and y. So we're trying to use r and theta to convert that into x and y. In order to do that, I need to create a right triangle. So this distance from the blue point to the x-axis is y, and this distance is x. Now, if I use sine of theta, that will be y over r, which means y will be equal to r times sine of theta. So in order to find this y value here, I will take r times sine of theta. And if I use cosine of theta, that will be x over r. And to find x, I'll just multiply both sides by r. So to find this x right here, I'll take r times cosine. So from polar, where I have r comma theta, and I want to convert that into rectangular, which has x and y, while x is r cosine theta and y is r sine theta. So if I'm given r theta, and if I want to convert that into rectangular, to find x, I use r times cosine theta. To find y, I use r times sine theta. And let's rewrite it down here. Example 3. Write the polar coordinates 3 pi half as the rectangular coordinates. They've given you the polar coordinates and they want to have the rectangular coordinates. So they given me r theta, they want to have x and y. So what I have is r equals 3 and theta equals pi over 2. Now I want x. X is r cosine theta and y is r sine theta. So let's first find x. X equals r times cosine of theta. R is 3 and theta is pi over 2. So x equals 3 times cosine of pi over 2. Cosine of pi over 2 is 0. 0 times 3 is 0. Next, let's find y. Y is equal to r times sine of theta. R is 3 and theta is pi over 2. Sine of pi over 2 is 1. 1 times 3 is 3. So my rectangular coordinates is a pair of x and y, which is 0, 3. In this question, they only ask you to convert from the polar coordinates to the rectangular coordinates. They didn't ask you to plot the points on the graph. However, I am including the polar grid and the rectangular grid right here so that we can plot the point on and compare them. As always, I will have my vertical and horizontal axis and also label them. My R is 3. That means I can scale this a little bigger. So instead of going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I can just scale this 1, 2, 3, 4, 5. R is 3. From the pole, I go to the right 3 units, 1, 2, 3. And theta is pi over 2. I will rotate in the counterclockwise direction, pi over 2. It's going to be this point right here. Over here on the rectangular grid, I will also draw on my vertical and horizontal axis. And the point on the rectangular coordinate is 0, 3. So 0, 3, this point right here. So as you can see, it doesn't matter if it's on the polar coordinate or rectangular coordinate, the points look different, they will end up with the same position. Next, we'll learn how to convert from the rectangular coordinates to the polar coordinates. That means they are going to give you x and y and want you to convert that into r and theta. It does not matter if you have x, y, or r theta. Once you plot the point, you will end up in the same position. In this case, they gave you x and y. They want you to find r and theta. So this is the right triangle. R is the hypotenuse. I am going to use the Pythagorean theorem to find r. R squared equals x squared plus y squared. So to find r, I'll just take the square root on both sides. R equals square root of x squared plus y squared. It was supposed to be plus or minus here, but again, r is the distance, so I only use the positive answer. Now, I have x and y, and I want to use x and y to find theta. Which trig function that involves with the opposite and the adjacent? That is tangent. Tangent of theta equals y over x. Example 4. Convert the rectangular coordinates 3, 3 to polar coordinates. They gave you x, y. They want to have r theta. Your x is 3, your y is also 3. So to find r, I am using the formula r equals square root of x squared plus y squared. X is 3 and y is 3, so I'm going to plug it in. R equals square root of 3 squared plus 3 squared. 3 squared is 9, 3 squared is 9, 9 plus 9 is 18. R equals square root of 18. Now, the question does not ask you to round or to give the approximation, so you want to leave this as exact answer. But square root of 18 is not simplifying. You need to simplify this square root, but leave it as exact answer. So I'm looking at 18. I'm going to break 18 to 9 times 2. The reason why I broke 18 into 9 times 2 instead of 3 times 6, because 9 is a perfect square. I will be able to take the square root of 9. So square root of 9 is 3. I will have r equals 3 root 2. Next, I am going to find theta. I will use tangent of theta equals y over x. Y is 3 and x is 3, so I'm going to plug that in. I have 3 over 3, which is 1. So I have tangent of theta equals 1. What is theta? Theta is tangent inverse of 1, which is pi over 4. So my polar coordinate is 3 root 2, comma, pi over 4. The question only asked me to convert from xy to r theta. They didn't ask me to plot the points. However, I'm including the grid here so that you can plot the points and you can compare them. So for the first one with the rectangular coordinates, I will have my x and y axis on first. And my point is 3, 3. So it's this point right here. So this point 3, 3 is in the first quadrant. That means when I plot the point in the polar coordinate n, it should be in the first quadrant as well. Three root 2 is about 4.2. If I put that into a calculator, 4.2 is somewhere here. And I will rotate it pi over 4 in the counterclockwise direction. Pi over 4 is half of pi over 2. So I will rotate it to here. This point is a point 3 root 2 pi over 4. One thing that I want you to notice here at this point, when tangent of theta equals 1, theta can either be in the first quadrant, pi over 4, or in the third quadrant, 3 pi over 4. In this case, I only use pi over 4 because I know that 3, 3 is in the first quadrant, so that's why this point should be on the first quadrant as well. If for some reason this point is negative 3, negative 3, you will have this point right here in the third quadrant, then at this theta, you will have to take 3 pi over 4, which you will have the points right here in the third quadrant. Example 7. Rewrite the Cartesian equation x squared plus y squared equals 6y as a polar equation. Cartesian equations are the equation in terms of x and y, and they want you to write it into the polar equation, which involves into r and theta. I'm looking at the equation here and trying to see if there's any relationship that I can use. X squared plus y squared. Remember in the previous page, when we're trying to solve for r, we use the equation r squared equals x squared plus y squared. So basically, I can substitute x squared plus y squared with r squared. So since r squared equals x squared plus y squared, I will substitute that with r squared equals 6y. So remember, polar equation will only have r and theta. I'm not allowed to have x or y in the polar equation. So I'm good on this part. But on this side, I have 6y. So remember, y is equivalent to r sine theta. So I am going to substitute y with r sine theta. So I have r squared equals 6r sine theta. So it's pretty much in the polar equation here. Next, all I do is just trying to simplify that. I'm going to bring 6r sine theta to the left side. So I have r squared minus 6r sine theta equals 0. And from these two terms, I have r is in common, so I'm going to factor out the r. Then I have r times r minus 6 sine theta equals 0. That means either r is equal to 0 or r minus 6 sine theta is equal to 0. Now, I'm thinking if I should take these two equations or if I should just take one or the other. So this r equal to 0, that means you have the point at the origin. By looking at this equation right here, this doesn't represent a point at the origin, so I'm going to reject this one. That means I end up with this equation, r minus 6 sine theta equals 0, or you can rewrite it to r equals 6 sine of theta. So from the Cartesian equation, x squared plus y squared equals 6y, I can have the polar equation r equals 6 sine theta. Example 8. Rewrite the Cartesian equation y equals 3x plus 2 as a polar equation. Remember, in a polar equation, you are not allowed to have x or y. You're only allowed to have r and theta. So from here, y can be replaced with r sine theta, and x can be replaced with r cosine theta. So I'm pretty much done having my polar equation, but next I need to simplify this a little bit. So let's say I'm going to bring the 3r cosine theta to the left side. So I have r sine theta minus 3r cosine theta equals 2. And from here, I'm going to factor out my r. And I'll have r times sine of theta minus 3 cosine of theta equals 2. And to solve for r, I will divide both sides by sine theta minus 3 cosine theta. And r is equal to 2 over sine theta minus 3 cosine theta. Example 9. Convert the polar equation r equals 2 secant of theta to a rectangular equation. So now in this example, I want the rectangular equation. That means I want to have x and y in my equation. I don't want r and theta. So this is the equation that they gave me. R equals 2 secant theta. This is the relationship between x, y, r, and theta. X equals r cosine of theta. Y equals r sine of theta. X squared plus y squared equals r squared. We don't have anything in secant. So if you have secant, tangent, cosecant, cotangent, you might want to rewrite it so that it's in terms of cosine or sine. So secant is 1 over cosine. So 2 secant is equivalent to 2 over cosine. So I'm going to replace it. R equals 2 over cosine theta. Now, I can only replace it if I have r cosine. I don't have r cosine here, but I notice I have r here. So what I'm going to do is multiply both sides by cosine of theta. So cosine got cancelled out. I have cosine of theta times r, which is r cosine of theta, equals 2. Now, I will replace this with x. This is my rectangular equation. And if I graph this on a rectangular grid, I will have a vertical line at x equal to 2.